what we're looking at today is sketching cubic functions or cubic functions. Okay, so your title for now is cubic functions. So when we've looked at linear functions, what did linear functions have in their equation? Linear functions. Linear functions are a straight line. And what did they have inside in their function? Not x squared, just x. X, yeah? Linear functions had x. A quadratic function, either that one or that one, had x squared in it. Okay? It's all right. So a cubic has x cubed in it. All right? Now a cubic looks like, now there's a few different ways of seeing a cubic. Okay? For example, y equals x cubed looks like this. That's a cubic. Okay? It's a bit more sort of straight across here, but we can deal with that. Okay? Could be more like this, but anyway, we're okay. All right? Another way of looking at a cubic might be like this one. Now this one, if I draw in a bit of a Cartesian plane, so you should be drawing this as well. This one goes through these points. And it looks like this. So a cubic can be just a sort of, the first one where there's no specific turning point, it just sort of goes into an even plane and then goes back up sharply again. Or it can have two turning points. So it can have no turning point, or it could have two turning points. Can anyone see any reasons why I could quickly find those points on that line from the equation? Julian? Perfect, okay. So what we're looking at is, because we're finding the x-intercepts and they're all in factor form, they're all being times by each other. If we make each of these sets of brackets equal 0, 0 equals x plus 2, x equals -2. Can you guys remember this from quadratics? We can find the roots of something by looking at the opposite number inside the brackets. So you might notice our roots are -2, -1, +2. And that's where that line is going through. How do I find that 0, -4 point? What's that 0, -4 point called? The y-intercept. And every time we find the y-intercept, how do we find we sub in x equals 0. And so that's how I found that point. So I did that sketch just quickly as I was writing up the equation. And that's what you guys should be able to do by the end of today's lesson. Okay, so I'm going to show you a bit slower how to do this. But you guys, by the end of this lesson, given a cubic in factor form, you should be able to sketch them. All right? So, our lesson for today, so that was just to show you the shapes. So you can have the shape, or you can have a shape with two turning points. So our lesson for today is about sketching cubics in factor form. So factor form means that there's things being multiplied together by each other. So hopefully there might be some brackets. Okay, when sketching, the things you're going to get marked on. the direction and shape of the line. So it's either going to be like this or it's going to be like this. I'll explain why in a second. The roots and the y-intercept. So you'll notice in quadratics you also had to find the turning point. Now you don't have to find the turning point ever for cubics. You only have to find the roots and the y-intercept. That's it. At the end though of any line, what do I do? If I drew a line, what do I have to also include? Arrows and label the equation. You should label the points as well, okay? So, and remember to add arrows and a label. Okay, so your marks are going to be for, it has to be in the right direction, so your line has to be going in the right way, okay? Your roots, so you need to label and show the roots. And the y-intercept, you need to label and show the y-intercept, and at the end put arrows and a label on it. Everyone okay with that? I'll show you how to do each of those three main things. So if we look at the direction, some people are still catching up. Do you like me to wait? Yeah? Sam? Pardon? Remember to add arrows. You'll get used to my writing after a while. Anytime you think it's a Z, it's probably an A. Alright? Alright. So to find the direction of the line, we've got positive and negative. Okay? So you've got a positive line. Now, positive line goes in this direction. A negative line goes in this direction. Now, if you look at the ends of the line, so ignoring the bump in the middle, you'll notice a positive line goes in a positive direction, just like a linear line would, and a negative line goes in a negative direction. If you just disregard the middle section, look at the ends, positive and negative, you should still be able to get there. So on the right hand side of the positive one, as you get further positive to the right, you also get further positive upwards, so you can see that it's positive at the end. Alright? So, y equals x to the power of 3 looks like this. Okay, there's not heaps of turning points. And y equals x to the power of negative 3 looks like that. So it's the same shape, they're just sort of flipped around in a different direction. Joe? Sorry, it's not y negative 3. Y negative x to the power of negative 3, sorry. That's why it wasn't making any sense. So negative x to the power of 3. Is that okay? Alright, so how do you think from an equation I can tell if it's negative or not? Julian? Good. Okay, so an equation is negative, a cubic is negative, if there is a negative at the front or a negative attached to an x or to a pronumeral, what would you say, x to an x inside. So, for example, y equals negative x plus 3, x take 2, x plus 1 is negative, because you've got this negative at the front here. Y equals x plus 4, 5 take x, x plus 3 is also negative because there's a negative here. However, we need to be aware that if there's both, if you've got two negatives inside, two negatives multiplied together become positive. So we need to make sure we write that. But if both, it will be positive. So for example, y equals negative x plus 3, negative x plus 2, x plus 4. In this one there are 2. So when we multiply them all together, it will become positive. So it's actually about multiplying the x's together. If we disregard all the other numbers, other than the negatives in front of the x's or the negative at the front, if it ends up being positive, it's positive. If it ends up being negative, it's negative. So if you had 3 negatives in there, it would be in the negative side. Okay, so if you had something like this, if you had something like this, y equals 3 take x, 4 take x, 6 take x. It's got 3 negative. It's got 3 negative x's. Negative times by negative times by negative equals negative x cubed. So it's a negative. Okay. So it's about, you don't normally get to that though. You normally only get 1 or 2 negatives in there, so you need to be aware of that. Now, whenever I look at sketching a cubic, the first thing I do is what direction is it in? And then I draw just a little shape there to remind myself. Because later on, once you've got all your points, you want to draw the shape perfectly. And by having that shape there, it reminds you of where to go. It also means that if you mess up something, so a lot of the time with negatives involved, people mess up their y-intercept. And so what happens is people try and do this shape and they can't. And so they know that they've got it wrong because they haven't got the right shape. Okay, so the first thing you do is you work out what shape your line's going to be in. Joe? No, so this one's negative. Because there's 3 negative x's. Okay? So this is 2 negative x's. Are there any questions? Julian? No, so it could also be any 2 negatives. So that would also be positive. Any other questions? All right, so we've said direction. We now need to work out the roots, okay? So to find the roots, how do we find the roots in an equation? Yep. The roots are the x-intercepts. How do we find them? Max?
Is that the before?
Yep.
The 8y equals 0?
Yeah, okay, so we use null factor law. We make y equals 0 and then we make each bracket equal 0, okay? So we make each bracket equal 0 and solve. Now I'll do an example of this afterwards. We'll just write the notes just all together and then we'll do examples, okay? If x is by itself, then one of the roots is 0. So 0, 0. I'll explain that again in a sec. And then the last rule for finding the roots, and this is new, so we haven't done this one in quadratics, is if one of the brackets or x, because it might be x by itself, is squared, then instead of going through that point, it just touches it and becomes a turning point. So most of the roots, the line goes through whatever that point is, but if it's squared, it becomes a turning point, and I'll show you what that means. We'll do it in a sec. We'll just finish off for the notes and then we'll do lots of examples, okay? Last one, how do we find the y-intercept? Sub in x equals 0 to solve for y. That's all our instructions. So all we need to do now is practice and make sure we understand what it means. Okay, so the rest will all be examples. It's a really bad line. All right, can we look at an example? Such as, we'll start with an easy one. Y equals x plus 4, x plus 2, x take 2. So the first thing we have to do is work out the direction. Are those x's all positives? Are the x's positive? Yes, so therefore it's a positive line. So the first thing I do is I draw a little sketch which shows a positive line just so that I remember which way I'm going. I then need to find the roots. To find the roots, we look at each set of brackets. And make them equal 0. And then we can solve. Negative 4 equals x. Negative 2 equals x. 2 equals x. And there are roots. You don't have to do that process of 0 equals. You can go straight to x equals negative 4. But just be aware that only works when it says x plus a number or x minus a number. It doesn't work if it's negative x. It doesn't work if it's like 2x. Okay, you'll actually have to do that step to work out what the answer is then. Are there any questions to there? Okay, what else do I need to find? Y-intercept. So, y equals 0 plus 4, 0 plus 2, 0 take 2. 4 times 2 times negative 2. Negative 16. So my y-intercept is 0, negative 16. Any questions? Those rules we did in quadratics. You see how it relates? Quadratic rule to find the roots, so it's always the same rule. Make each of the brackets equal 0. Find the y-intercept, it's always the same rule. Sub in x equals 0. Just that we're using a different sort of equation. So, I then just, now the thing is with sketching, You almost never get given graph paper, you just get given a Cartesian plane like that. So it doesn't have to be to scale, but it does have to look accurate. Some of my year 12s just decide to write all of theirs like that and then put in the numbers. Okay? That's not accurate. They have to look like at least you've put in the effort. Okay? So the first step you do is you draw in the actual points. So we go, okay, we need to put in -4, so approximately -4, -2, and 2. See how they're close to being somewhere, they could be close to those points if I actually got a ruler out, okay? As close as possible to what you can do. I also need to go -16, and put a point there, and we label them all. 0, -16. 2, 0. -2, 0. -4, 0. Just having those points there, even before you put the line in, will get you a lot of marks. Because you're showing, pardon? Well, once we put the line in, the Cartesian plane doesn't matter. Because you've shown me, you know where the roots are, you know where the y-intercept is. So the only other mark you're missing is, I know the direction of the line. And so up higher, we did that little sketch like that, and I'm going, okay, this line starts in the bottom left-hand corner. So before the first point, so before this -4, 1 point, I need to go, let's go further to the left and down from there. Because that's where this line starts, bottom left-hand corner. So I go down here, and I go, okay, it then goes up, it needs to go through that point. I then need to turn to get through the next point. I need to get through the y-intercept. And then up through the next one. Arrows. An equation. And you're done. Which one?
Like, so from in between the -4 and -2, it's like...
Yep, okay. In 2CD, we're not expecting you to know how to find the turning point because it's really complicated. So we're only expecting, so those three things, you have to find the roots, you have to find the y-intercept, and you have to know the direction. You don't have to be, it's not accurate, like if I said graph it, and you had your calculator, it would be expected that you had all those points in perfect place. But because it's a sketch, this would be in a non-calculator section, it doesn't matter. Does that make sense?
Yeah.
So it's just like this point as the y-intercept might not be the actual turning point. The turning point might be a little bit to the left or a little bit to the right, we don't know. But as long as we show those points and we put it in the right direction, we're okay with that. Okay? Jesse? 3 or 4? Depending on what they ask you for. It shouldn't take you too long. Okay, your homework's going to be to do about 24 of these. Shouldn't take you more than 20 minutes max. It's quick, once you get the hang of it, okay? But we need to get into the harder ones. So this is the first easy one. Yeah, but how long did that take? Nothing. All right. Okay. Everyone okay with that one? Let's go to one step harder. We'll do 2 steps harder, so we won't have to do too many examples, okay? Let's go this one. Y equals x, 3 minus x, x plus 4. Okay, first thing is this positive or negative? It's negative because it's got this negative x in it. So that means it goes in this direction. Okay? The roots, how do I find the roots? What's the root for this x here? 0. As soon as you see x by itself, it's a 0. Okay? Now, that also tells us something about the y-intercept. It's through the origin, okay? So we don't even need to find the y-intercept because if one of the roots is 0, 0, that's what the y-intercept is. Okay? 3 take x. This one we actually have to make it equal 0 and work out the answer. So 3 equals 0. So beware of that one. It's not the opposite. It's the same number. So that's our other root. What about this one? X equals -4. So that's we've got 3 roots there. Our y-intercept, if we sub in x equals 0, if 0 is here, anything multiplied by 0 is 0. Okay, so it's that point. I'll show you. So, if I go y equals 0, 3 take 0, 0 plus 4, y equals 0 times 3 times 4, anything times by 0 equals 0. Josh? Yes. Thank you. Thank you. Jesse? Yeah. You still have to find all the other routes because the line still goes through those routes, but you don't need to find the y-intercept because you know that straight away. So if we plot these points, it'll take us less than a minute to plot this, okay? So you just have your lines. You've got 3, -4, so -4, 0, 0, 0, 3, 0. We know the line goes in this direction. So we start in the top left this time. Arrows and equation. And you're done. We're going to do one more together and then I'll get you guys started on your homework and I'll go through some of the homework questions if people are still having trouble. All right? Joe? You should be able to get it on that point because there are only 3 points you have to get it on. So yes, you should be getting it on the point. One off is okay, but for your test you want to make sure it's perfect. And that's why you use a eraser and a pencil. Okay? All right. We okay with that? Okay, let's go one step harder. Y equals -x, x plus 3 squared. -x, x plus 3 squared. Now, in the rules for the roots, I told you a little bit of a rule if it said squared. What did I say about if it says squared? It's a turning point. It touches that point, so it's still a root. It touches that point, but doesn't go through it. It touches it, and then it becomes a turning point. So, what's this one for the root there? 0. What about this one? -3, but it just touches that point. Is this a positive line or a negative line? Negative. So -x at the front. Now, the bit where people had trouble in my year 12 class with this was with the y-intercept. We still, actually it won't be with this question, but normally, you still need to include the negative. Why won't it be a problem for this one? Because you don't have a -0, you already know it's the origin. But if you had -2 there, you'd still have to use it as a negative and then a 2. So the negative still counts. But we know that straight away 0, 0. Alright? So, we've only got 2 points on this line. We've got 0, 0, and we've got -3. But we know the line has to go like this. So, I start top left-hand corner. I get to this line, and what do I do when I get to this line? I go back up. It becomes a turning point. I go back up. I then need to turn back to get to here. That's my line. And that's it. So if it's squared, it doesn't go through the line, it turns into a turning point. And you should now be able to sketch cubics.